Good morning, everyone. Now let's talk about the derivation of law of sines. Let's have an agreement on labeling the parts of an oblique triangles. Let the angles be labeled as A, B, and C, and let the side opposite them be labeled as A, B, and C, respectively. Take note, if it is an angle, it is a capital letter, like angle A here, B, and C. If it is a side, it is a small letter. So we have here angle A. The opposite side of angle A is here. So this is side A. The opposite side of angle B is this side. So this is side B. And the opposite side of angle C is this side. So this is side C. With the given information provided above, let us now draw segment CD perpendicular to AB. And let's label CD as H, which is the height of the triangle. Note that H separates triangle ABC into two congruent triangles, right triangle CDA and right triangle CDB. Using the figure on a previous slide, let us show that sine angle A over A is equal to sine angle B over B. Let's use the yellow triangle in a right triangle CDA with right angle at angle D. To find sine angle A, the first thing to do is to label the parts of the right triangle. From this figure, side B is the longest leg of a right triangle, so this is our hypotenuse. Next, with respect to angle A, H is our opposite side. Then, sine angle A is equal to H over B. Now, let's rewrite this equation in terms of H by applying cross product property. So, we have here H is equal to B sine angle B. Let's now use the light blue right triangle. We have here right triangle CDB at right angle at angle D. Let's find sine angle B. To find that, the first thing to do is to label the parts of the right triangle. Side A here is the longest leg of our right triangle, so this is our hypotenuse. With respect to angle B, H is our opposite. Therefore, sine angle B is equal to H over A. Now, let's write it in terms of H by applying cross product property. So we have here H is equal to A sine angle B. Observe that H here is equal to B sine angle A and H here is also equal to A sine angle B. Therefore, these two are equal. Therefore, A sine angle B is equal to B sine angle A. To show that sine A over A is equal to sine B over B, we need to apply multiplication property of equality by multiplying 1 over AB on both sides of our equation. So we have here 1 times A sine angle B is 1. A sine angle B over AB is equal to B sine angle A times 1 is B sine angle A over AB. Observe that we can eliminate A here and B here. Therefore, sine angle B over B is equal to sine angle A over A. We have given that triangle ABC. The opposite side of angle A is side BC, so this is named as side A. The opposite side of angle B is side AC, so this is named as side B. And the opposite side of angle C is side AB, and this is named as side. Let us now draw segment AE perpendicular to BC or CB. And let's label AE as H, which is the height of the triangle. Note that this H separates the triangle ABC into two right triangles, right triangle CEA and right triangle BEA. Using the figure on the previous slides, let us show that sine angle B over B is equal to sine angle C over C. Let's use the orange right triangle CEA with right angle at angle C. Let's find sine angle C. So label the parts of the right triangle. B is our hypotenuse since it is the longest leg. And with respect to angle C, H is our opposite side. Then sine angle C is equal to H over B. Let's write it in terms of H by applying cross product property. So we have here H is equal to B sine angle C. Let's now use the light blue right triangle BEA with right angle at angle E. Let's find sine angle B. To do that, let's label the parts of the right triangle. C is the longest leg of the right triangle, therefore it is the hypotenuse. With respect to angle B, H is our opposite. Then sine angle B is equal to H over C. Let's write it in terms of H by applying cross product property. So we have here H is equal to B sine angle B. Observe that H here is equal to B sine angle C and H here is equal to C sine angle B. Therefore, these two are equal. Using the previous information, so we have here B sine angle C is equal to C sine angle B. And to show that sine angle B over B is equal to sine angle C over C, we need to multiply both sides by 1 over BC. So 1 times B sine angle C is B sine angle C over BC is equal to 1 times C sine angle B is C sine angle B over BC. Observe that we can cancel out B here and C here. Therefore, sine angle C over side C is equal to sine angle B over side B. By transitivity, we can conclude that sine angle A over A is equal to sine angle B over B is equal to sine angle C over C.